Okay, 9.2 homework is in the binomial theorem. So we're going to expand this, this linear factor to the fifth power. So when we do that, the best way to do it is with the binomial theorem. What we're going to do is we're going to do 5c0, and then we're going to take the first term, which is 2x, put it in parentheses, raise that to the fifth power. Take the second term, which is just a 1, raise that to the 0th power. And now we're going to follow this pattern where we increase this number, decrease this number, and increase this number until we get to the end. So this would be 5c1, 2x to the fourth, 1 to the first, and we're just going to keep following that pattern. 5c to the second, 2x to the third, 1 to the second power, and we're going to keep going. Okay, so when you write it all out, you get this. I had to go down to this next line here. But now we can just simplify this. These come from Pascal's triangle. These come from the fifth row of Pascal's triangle. Or you can do them in your calculator. So if you don't know the fifth row of Pascal's triangle, one easy way to get it is to go to y equals and just type in, I'm sorry, I need to be in regular function mode. So under y equals, you can type in 5 and then go to math, scroll over to probability, and do the NC. Only instead of putting an actual number there, put a variable x, because then it'll do NC0, NC1, and so on. Go to your second table, start at 0, go by increments of 1, and just look at your table real quick. And here's the row, 1, 5, 10, 10, 5, 1. So what that means then is this is 1, this is 5, this is 10, this is 10, this is 5, and this is 1. Those coefficients come from the fifth row of Pascal's triangle. So now I can simplify this pretty easily. 2 to the fifth is 32. That's just a 1, so this first term becomes 32 x to the fifth. 1 to the 0th is just, so these are always going to cancel out as well, which is nice for this first one. And then I have 5 times 2 to the fourth. So 2 to the fourth is 16. 16 times 5 is 80. So we have 80 x to the fourth plus, next one I have 10, and then I have 2 to the third, which is 8. So I have 8 times 10, which is 80. So 80 x to the third plus, next one I have 2 to the second power, which is 4, times 10 is 40. So it'll be 40 x squared. And then down here I have 5, and then this is just 2x, so it'd be 10x. And then the last one I have 1. This just drops out to 1. This is just 1, so it's just plus 1. So there's my answer, and I just put these coefficients in here. So 32, 80, 80, 40, 10, and 1. Now, by the way, Pascal's triangle is symmetric, so that you'll notice that this 1, 5, 10, 10, 5, 1 is symmetric, which means that you could have went 5c5 here, and then went 5c4, 5c3, and went the other way with the coefficients, and you'd get the same exact answer. Keep that in mind. So for the next problem then, when it wants us to find the coefficient on just one term, that's where x to the 9th y squared, then we could do 11c9 or 11c2. It doesn't matter. These are symmetric, so they're going to be the same. I'll do the 9, in which case this is 2x to the 9th power, and then negative 3y squared. So these will give the same thing. All right. So the second one then becomes 9y squared. If I square that, this becomes 2 to the 9th, x to the 9th, and then 11c9, if you do that in your calculator, or 11c2, you get 55. I need to multiply these things together. If I multiply the 55 times 2 to the 9th times 9 in my calculator, because order doesn't matter when you're multiplying, you get a really big number, which is the number we're looking for, which is 253,440. And then obviously it's x to the 9th y squared, which is the, they wanted the coefficient, so they want this number right here. Okay, this next one's a little bit harder. It wants the coefficient on x to the 8th, y to the 9th. But this is a 7, and these already have powers here. So you got to think about what would I raise 2 to get 8? And that answer would be, if I took this term and raised it to the 4th power, you'd multiply the exponents and you get that 8. So that's the key, because then the next one, 2y cubed, would be to the 3rd power if you follow the pattern of the binomial theorem. And the coefficient then would be 7c4 or 7c3, either way, because it's symmetric like we said. So if we do this in the calculator, this will give us the coefficient and simplify. 7c4 is 35, 2 to the 4th power is 16, 2 to the 3rd power is 8, I'm sorry, and then I have to do x squared to the 4th power, which is x to the 8th. And then y cubed to the 3rd power is y to the 9th. So then I can just simplify by multiplying out these numbers and putting that number in front, which if you do that in your calculator, you get 4,480. And that's the number they're looking for right there. All right, we can try a few really tricky problems now, like this next one, number 4. We want to find the constant term. So the constant term is going to be tricky to find here because we know we have this pattern where we raise this to some power, like say 48, and then the next term would be 5 over x to the 0th, for example. That's where we would start, where this would be 48c0 to start. Now, that's not the constant term though, because this gives you x to some really big power, and that's not the constant term. The constant term has x to the 0th, so there's no x. So that doesn't work. So we're gonna have to basically just like try different things and see which works for us. I mean, you could try then the other way around, which would be a 0 here and a 48 here, but that's not a constant term either, because that gives us x to the 48 in the denominator here, or x to the negative 48. So the constant term is tricky, but if you imagine multiplying x to the 7th times 5x, you have x to the 7th times 5 over x. One of these x's is going to cancel, so there's a point where we can get the exponent the same here as here. So let me call this like y. This would obviously then be 48 minus y for our pattern. And now think about just the variable. So think about this is 7 times y. We want the exponents to be the same here. And in the bottom here, this is a 1. So I want this exponent in the bottom to be the same so that they cancel. So that's going to be the same as 1 times 48 minus y. And then you can solve this. So you get 7y equals 48 minus y. Add y to both sides. 8y equals 48. Divide both sides by 8. You get y equals 6. So what that tells us is if this were a 6 right here, and if this were then a 42 right here, and I raise this, you can see that you get the same thing. This would be x to the 42 right here for this variable times, and then in the bottom you'd have x to the 42 here, and they would cancel and you'd just get a constant term. So that's what I'm looking for. Let me fill out the rest of this though. Negative 5 to the 6th power, 15,625, but actually I'm just going to leave this as negative 5 to the 6th power. And I'll leave this 5 to the 42nd power. So these cancel, but I still have this 48c6 in front. So you want to enter this in. You can get rid of these. And then 48c6, I don't know how to write that without writing it as a number. So if you do it in your calculator, you get this number here. So this is the best way to write it in, just like that. I know it's kind of a pain to write in. I wrote it in like this, where I used extra parentheses here around the whole first term and then around the whole second term to make sure it multiplied. I'm not sure you needed to do that, but hopefully that helps. The next problem is a lot easier. Which term of this expansion contains x to the 5th? That's the 5th term. You start off with 9c0 x to the 9th, 7 to the 0th, and that's the first term. And then you have 9c1 x to the 8th power, 7 to the 1st power. So if you work your way, you can say that's term number 5. Because you have, if you oversimplify this is x to the 9th, then you have x to the 8th, then you have x to the 7th, then you have x to the 6th, then you have x to the 5th. So we have 1st, 2nd, 3rd, 4th, 5th term. Okay, this next one's a little tricky too. It wants the 10th term, so we know we're going to have 14c we start off with 14c0, and then 1 to the, I usually do 14th power, and then negative 1 over n to the 0th. So there's the first term. So you can kind of follow this pattern. The second term would have a 1 here, and this would be 13, and this would be 1. That's the second term. The third term, this would be a 2, this would be a 2, and this would be a 12. So you can imagine the 10th term, then this would be a 9, this would be a 9, and this would be then a 5. So if you simplify this out, this number gives you 2002. 1 to the 5th is just 1. Negative number to the 9th power is a negative. I'll put that out front. Times 1 over n to the 9th. So I'll just put n to the 9th in the bottom here. So here's our answer right there for the 10th term of this binomial expansion. Okay, for this next one, we want the 4th term. So we have 8c0 is our first term. So 0c1 would be our second term, and so on. So following that logic, then we need 8c3. And following the pattern that we have been using, this would be 3, and this would be 8 minus 3, which is 5. So that's the term we're looking for the 4th term. We have to multiply this out. So if you do this in your calculator, 8c3, you get 56 there. This is x to the 5th. Negative 4 to the 3rd power is 64, so this is negative 64y cubed. So I can multiply these numbers together, and that gives me negative 3,584 x to the 5th y cubed. There's my answer right there. Okay, the last problem wants to write out the first 4 terms. So we have 7c, you can start with 7c0 or 7c7. Doesn't matter. I've been starting with 7c0, and then this to the highest power, and then the other one to the lowest power. And it wants the first 4 terms, so we have to follow that pattern. 7c1 now, 3 to the 6th power, negative 1 over n to the first. And then we have 7c2, 3 to the 5th, negative 1 over n to the second. And then one more, 7c3, 3 to the 5th, negative 1 over n to the third. There's the first 4 terms. We do need to simplify those. If we do that, this is obviously 1, and this is obviously 7. And then if you do this in your calculator, you get 21. If you do this one in your calculator, you get 35. So to simplify this, this goes to 1. So my first term is just 3 to the 7th power, which I could probably just enter in as 3 to the 7th. And I don't need to write, that can be my last term since that's my constant term. It probably doesn't matter. Next one simplifies to 7 times 3 to the 6th power times negative 1 over n, which you could probably simplify that a little bit to negative 5,103 over n if you want. So that takes care of the first 2. Let me get rid of those. Now we have these last 2 here. So we have 21 times 3 to the 5th times, this is going to be a positive 1 over n squared, which I guess I could simplify this a little, to 5,103 over n squared. And then the last one, we have 35 times 3 to the 5th times, this is going to be negative 1 over n cubed. So I'm going to put the negative sign out front, simplify it a little bit, and I get, and actually this is supposed to be a 4 right here. I didn't drop that when I was doing this. This should be a 4, which gives you negative 2,835 over n cubed. So I know it's a little difficult to enter n, but that would be the